Hey, this is DW, and I just thought I would check in with my Excel bootcamp videos. The thing is, you always want to begin with why. Why would we do an Excel bootcamp when we're supposed to be teaching physical chemistry? I mean, physical chemistry deals with volume and temperature, pressure, energy exchange, all of these things that are related to chemical reactions, and then even at the end of the year, nuclear reactions. So what does Excel have to do with it? Well, I like to use this analogy. We've set forward a whole feast of science for this year, but you can't enjoy the feast if you're constantly dropping the silverware. And so Excel for this course is the ubiquitous silverware. It's what you use to pull the chemical information out of several scientific experiments, various spectroscopic experiments. So let's look at some of the examples of spreadsheets that you're going to need to build this semester, and we'll guide you through these things in terms of the lab manual and with the help in by the TA in the lab sections. And so early on, we start with a particle in a box. And so the particle in a box example is you've got wave functions plotted with each other and looking at the different behaviors of waves. We eventually turn this into a realistic looking spectrum. To enable you to do this spectral simulation, you need to know quite a few functions and formulas. Underneath all of these curves are several transitions that you can see, and you'll need to be able to plot all of these on the same graph so that you can understand that underneath this peak, and in fact underneath all three of these, what you might say in a visible spectrum is 3 peaks, is really 120 transitions. Moving on to a different lab experience, we have the Raman and infrared data for acetonitrile that we plot on top of each other. And underneath that we have the Gaussian simulation. Now the Gaussian just gives you XY values for the transitions. It doesn't give you all of the data that you see up here in the spectra. So we need to be able to produce a stick spectrum. And so this is an example of a stick spectrum. We even saw this in the previous spreadsheet right here. These vertical lines here, that's a stick spectrum for the transitions in a particle in a box. On top of that, we've put instrumental line shape. So going back to the Raman spectrum and the IR spectrum for acetonitrile, we need to be able to plot multiple experimental data sets on top of each other. And even though there are other spectral packages that we could use, like grams from Thermo, Origin, maybe you could even program R to produce these kinds of spectra. I think that it's useful to learn Excel because you'll have Excel in just about any workspace. So no matter where you get a job from here on, you'll be able to use Excel. Moving on to another lab, we have the color lab. Now in the color lab, we look at the various reflectance colors or transmittance colors of objects that you bring. And in order to do this, we need to know how to do matrix multiplication. So some of these array formulas that we see up here are actually matrix formulas. And so you need to know how to do matrix multiplication in Excel. Well, if you can't do that, you can't enjoy this feast, which is the color lab. Also, this is a XY scatter plot, but in order to plot it on top of the chromaticity diagram, we were able to load an image in the background of this plot. And so that's a handy tool to be able to do. In the carbon monoxide lab for peak picking, you can do this the slow and tedious way, and you can do it in a little faster way if you learn some of the tools in Excel. So working smarter, not harder is definitely a feature in this course. And then finally we end up with the iodine lab, where we need to construct some very strange tables, like a Deslanders table, where you have all kinds of differences programmed in. Along the way, you'll learn some handy tricks too, to enable you to use Greek characters in cells, subscripts, superscripts, and so on. So you'll come out of the course not only with a knowledge of chemistry, but with a deep knowledge of how to use Excel to present data in new and exciting ways for you, I'm sure. So these are just some examples of some of the data analyses that we'll do throughout the course. It's just an enormous amount of data crunching that is part of this course, and you just can't imagine what you'll be able to do when you finish. So that's why we need to have this Excel boot camp. Now, most of these skills are taught within the lab, so you don't need to learn it all up front before the semester begins. But I wanted to put these videos out there to teach you specific skills so that you can revisit them. If you think, gee, I don't quite remember how to plot multiple lines on a graph, then you can go back and check that video. Or anchoring cells, if you've forgotten the details, essentially the only detail is F4, function key 4, then you can go back to the video and get a deeper explanation. Well, hopefully that explains why we're having this Excel boot camp, and also gives you a sneak preview into all of the fantastic data that we're going to be crunching this fall. So hopefully you'll enjoy the semester. I know that by the time you finish, you can ask the alumni on Facebook and Instagram how much they value the skills they learn, not just in chemistry, but also in Excel. So have a nice week.